section 6.2 volumes. So in this section we are going to see how to find out the volume of a solid. Different shapes we will see and different methods. But before we start, if we have one of these shapes, which are each of them can be called a cylinder actually, because the volume of a cylinder is area of the base into height, or you can say V is equal to A times H, where A is the area of the base, or you can say of cross section. So for example, this first one, its base is a circle. So a circle has an area pi r square. If the radius of the circle is r, then the area of the circle is pi r square. And h is the height. So h is the height of this solid. What is the name of this solid? This is a cylinder. So pi r square h is the volume of the cylinder. If you notice, I put parentheses around pi r square, so this is the area of the base, or sometimes we say area of cross section. Cross section means you take a thin sharp knife, or a maybe think of like cutting through this cylinder horizontally. So you will make a cut like this. So this is the cross section. The area of this is the area of the cross section. So you see that you will get circles when you make a cut. So the area of the cross section is the area of a circle. Now in the second example shape, we can call it maybe a box. So with a square base. So both of these sides are x same. The height is different. So we can say the formula for the volume is x into x into h, which becomes x square h. So the V is equal to x into h, which becomes x square h. Now think about it. What is x square? X square is the area of the base. Area of the base. So we can see that the area volume can be written as area of the base times the height. Same thing here in the third picture. So we have x, y, z. We have three sides, or you can say LMN, or you can say length, width, height, or length, depth, height, whatever. So you will see that we multiply all three to get the volume. And again, what is the base? What is the area of the base, or area of a cross section? So in this case, the cross section will be like this. So you will get a rectangle with area x times y, and height is z. In here also, remember, we had a cross section. Area will be a square with sides x. So this is how we look at the volume. So now what about a general type of solid? So something like, for example, something like that. Well, we can do it. Actually, we don't know the function right now. But we can cut slices. So we can say volume of a solid by slicing. So this is what we do. So I have this is not a box actually, but like a shape where this portion is smaller than the portion on the right. So it because this is a slant line. So how do we do this? So first thing is we assume that this shape is aligned with the x-axis, so that when we cut pieces or slabs out of this, those slabs are perpendicular to the x-axis. So the cross section, to get the cross section, we have to cut it parallel to y-axis or perpendicular to x-axis. So how do we do that? Basically, how we did it for the area. So we have our interval AB. We divided it into n subintervals. Pick an arbitrary interval with xk minus 1, xk as its endpoints. So remember, xk minus 1 is equal to delta x. This is what we learned in the first section, 6.1. Actually, in chapter 5 we learned that, but now we pick an arbitrary point inside this interval. Where should it be? It doesn't matter. Should it be in the middle? Yes, it can be in the middle. Should it be anywhere else? Yes, inside the interval, anywhere. We pick an arbitrary point. We denote it by xk star, this one. And then on that interval, we had a slab or a slice of the shape cut out, and I brought this slice over here, just zoomed in. So area of the cross section will be this piece, and the thickness is delta x. Now if we say let a xk star be the cross-sectional area of an arbitrary slab and vk be the volume of the slab, then vk will be equal to the area of the base multiplied by the height. In this case, the height is just this much, which is delta x. So we get vk is equal to a sub k star delta x. Now we will have bunch of these slices. So how we find the volume? We add them all up. We add the volume of each slice from 1 through n, and so that gives us an approximate volume. So v is equal to summation k is equal to 1 to n a sub k star times delta x. So this is the approximate value. How do we get the exact value? We take the limit. We let n go to infinity. Limit of this sum here, and then what happened? We learned that it becomes an integral. So we can write it as integral from a to b, a x dx. So remember, and it becomes integral, this goes away. Now we have a variable x dx. So this is how we calculate the now if the slabs that we are going to cut through or get slice are perpendicular to y-axis, then the volume will be given by v is equal to c to d, where c is to d, and f of a of y. Now the area will be a function of y, okay, and dy. So this is what we. So let's look at first example. This says find the volume of the given solid. and given solid is this, and this is a cylinder. It is it's lying on the x-axis, so x-axis is actually passing through the center. So it says 1 here. It says the radius of the circle will be 1, and if we cut a slice or a slab somewhere, what will be the area of this? Because the cross section will be a circle, so the area will be pi r square, but r is 1, so we get pi into 1 square or just pi. So that is the area, and now we have to integrate. So we integrate, v will be equal to, actually I did it over here, so v is equal to integral of pi dx, because our ax is pi, so 1 to 4, because these points, this is 1, first one, and this one is 4, so a is 1, b is 4. So now integrate from 1 to 4 pi dx. Pi can be pulled out because it's a constant, so we are left with pi times integral of from 1 to 4 1 dx, or just dx, and this gives you pi x 1 to 4. So when you plug in the limits, we get pi into 4 minus 1, which is equal to 3 pi. So the volume of this cylinder is 3 pi. And if we now look, so this is like with using calculus kind of, we found the value of the volume. But what if we have, we think about it with the formula, the area of the base times height. So area of the base will be, so the base looks like a circle. So area of the base is pi r into 1 square times height. What is the height? So this will be, the length is the basically the height. So 4 minus 1, which gives you 3 pi. So we got this one. Okay, the next thing we are going to look at is solids of revolution and disk method. First, there is another method also we will learn in this section, that is called shell method. But first let's look at this one. Now what is the solid of revolution, or what are solids of revolution? So if we have a plane, a region in the plane, and we revolve it around a line in the plane, we get a solid, and that solid is called solid of revolution. And the line about which it is revolved is called the axis of revolution. So here are some typical shapes. So if you have a function, you have a region like this, a rectangular region. If you revolve it around this axis, x-axis, so doesn't matter if you go clockwise or anti-clockwise, just we have to revolve it. So if I put my arrow like this, it means we are going clockwise, and if I put my arrow in the other direction, then it will be anti-clockwise. But doesn't matter. What will we end up with? We will end up with this shape. So when you will revolve it, we'll get a cylinder. here be, this is semicircle, the next one. So when you revolve it about the x-axis, it will give you a sphere. This is a triangle. When you revolve this one, you will end up getting a cone. Now we have formulas, we know the formulas for these shapes. The volume of the sphere is 4 by 3 pi r cube. And this one is, I believe, 1 by 3 pi r square h. So what is h? H is the height of the cone. So this will be your h, and r will be the radius of the base. Anyhow, so we are good with those type of shapes. But what if we get a shape like this? So we have this region, and we revolve it around the x-axis. So what happened? We get a shape like that. How do we figure out the volume of this shape? So let's see. Now basically idea is that we will do the same thing, that we will cut slices. In this case, what the slice will look like. In this case, we know what the slice is going to look like because we revolved it around the around x-axis. So when you revolve the region around any line, then if you cut the slices or the cross section, that will be a circle or a disc. That's why it is called disc method. So that's what will we do. So notice here, the cross section of the solid perpendicular to x-axis will be discs. With what? What is attached with the circle? Radius. So we want to know what is the radius of that circle. So note here that the x-axis is here, and if I go, how much is that? That is f of x, and that is the radius of the disc which you can cut at this here. In the same way, if I make the disc over here, what is this? This is the radius. How much is that? F of x. So I hope you understand that we are getting discs with radius f of x, because f of x is changing. See, changing. So the radius of the discs will change. So that now that we know that it is a circle, and we will use the same formula we derived earlier, that the volume is area multiplied by the area of the cross section multiplied by the thickness or length. So when we get those discs, they will have a thickness dx. So we get x-axis will be discs with radius f of x. So the area of a typical disc will be what? So I mentioned earlier the formula for the area of a circle is pi r square. But what is our r here? F of x. So area will be equal to pi into f of x whole squared. Pi is not squared, remember, only the radius is squared. So the volume of the solid will be, so this is our formula, will be replaced, x will be replaced by this quantity. So we get pi into f of x whole squared dx. That will be our volume. Okay, now in copying this for similarly, if the solid is of revolution is obtained by revolving a region bounded by x is equal to f of y, the y-axis y is equal to c and y is equal to d, like this region. Then the slices are again disks with radius f of y, because if you, here is slice, so radius will be from the y-axis to the curve, which is f of y. So in this case, the volume will become integral from c to d pi f of y whole square dy. Okay, so what are the steps here? Sketch the region. Now, to sketch the region, actually, sometimes there are can be more than one function which bounds the region. So in that case, you will have to find the points of intersection. The next is sketch the solid, means what you saw here. This is the region, this is the solid. Then draw a typical disk. So in the solid, draw a typical disk that will be, kind of, we are going to take, and then determine a formula for the cross-sectional area. In other words, if whether we are going to use the one with the x or are we going to use the one with the y, because remember the area of the disk will always be pi into the function square, because it's always going to be a circular disk. And then we integrate the area over the appropriate limits to get the volume. So let's look at the first example here. So it says find the volume of the solid obtained by revolving the region bounded by the curves y is equal to e to the x, y is equal to 0, x is equal to -1 and x is equal to 1 about the x-axis. I would always try to graph the function, and then so first I will draw or sketch the region. What region are we talking about? So we have the function y is equal to e to the x. This is 1. So this is e to the x. And then y is equal to 0 means the x-axis. X is equal to -1. So somewhere here we will have -1. So we put that line, and x is equal to 1. We have 1. So this is our piece. So when we revolve it about the x-axis, what do we get? So again, I'm now only going to draw the piece. So this is our piece. We revolve it. this is something we get. Okay, so you can see a typical disk would be with radius. Okay, it's a little bit weird because this should have been the same. Okay, I'll redraw it. Yeah. So a disk for example here. So what is the radius? This is the radius, and what is that? That is f of x or e to the x. So area, we will say the cross section is a disk with radius f of x. Therefore, a of x will be pi into f of x square. F of x is equal to e to the x. So I will say e to the x whole squared. So we get pi e to the 2x. So that is our, 2x. So this is basically square gets, this 2 gets multiplied with this x, rule of exponents. So now v will be equal to integral. Okay, where is the integral from? Because we know we started at -1 and we ended at 1. So integral from -1 to 1 pi ax dx. So just a dx, but a dx is this. So we get integral from -1 to 1 pi into e to the 2x dx. You can pull the pi out. Okay, now how will we do that? Well, you can do it by substitution. So you can say let u equals 2x, then du will be equal to 2 dx. Now do you want to change the limits or do you not? That's up to you. Let's not change them and we will put them in the end. So dx, this will give us dx equals 1/2 du. So our v becomes pi into e to the u du over 2. Okay, I can pull this 2 out, so I get is equal to pi over 2 integral -1 to 1 eu du. Now integral of e to the u will be e to the u. So pi over 2, okay, we are taking the integral now. So e to the u will give me e to the u. And then I will change it to x. Now I will put the limits. Pi over 2 stays outside. Apply the upper limit, so I get e to the 2 minus e to the -2, and that is your answer. You could also write it like this if you want, but don't need to. I think this is a nice formula. I will leave here. Okay, next example. Find the volume of the solid obtained by rotating the region bounded by the curves 2x is equal to y square and x is equal to 0 and y is equal to 4 about the y-axis. So first thing I will do is draw the region. Two x is equal to y square. So 2x is equal to y square means x will be equal to 1/2 y square or y square over 2. So remember, something like this is a parabola opening to the right. So it will be a parabola like this. So it's just that it will be a little bit narrow one. X is equal to 0 is the y-axis. So we have y-axis here and y is equal to 4. So this means it will actually be so we notice that we have this region that we are talking about. So I don't need to this piece of the parabola. So I'll get rid of that, just this much. That is our region and we are going to revolve it around the y-axis. So you can see what will happen. get this solid of this shape. So if I draw a disc, going to look like that, and radius will be the half of this. This is what? This is the distance from the y-axis, so it is, you can say this is x, but what is x? X is 1/2 y square. So cross section is a disc with radius 1/2 y square. So area will be equal to pi into 1/2 y square whole square. So which will be pi into 1/4 y to the 4, or pi over 4 y to the 4. So the area volume will be limits. Where are the limits going? So limits are on the y-axis, so they go from 0 to 4. How can we find the limits? Remember, we can put these two equations together. X is equal to this and x is equal to 0 means you can find the points of intersection of 1/2 y square is equal to 0, which it gives you 0. Then you put the so you got the 0 for y, and then about the line we have x is equal to 4, which is y is equal to 4, which is the horizontal line up here, and that's will be the bound, and 0 to 4 and pi over 4 y to the 4 dy. Okay, so this becomes pi over 20 y to the 5 and 0 to 4. So what do we get? Well, pi over 20, and let me write this as 4 into 4 into 4 into 4 into 4. 1 4 cancels this with 5, and the rest of the 4s, they gave me 265 because it's 16 square. So this is gone. These two 16, these two multiply 16, 16 into 16 is 256. So 256 pi over 5. So that will be the volume of this. Okay, I will stop here and do the next problems in another video.